Hi guys, here is your lesson as we get ready to really dive into some of these identities that we'll work with our trigonomic functions. So if you read sort of the beginning blurb here, it says, in math, identities are statements that are true no matter what numbers we plug in. So for example, in Algebra 1, we learned that x squared minus y squared is equal to x minus y times x plus y. And we know that this is true for all values of x and y. So there are some identities that exist that are within these relationships of these trigonomic functions that we've been graphing and working through. So we are going to go ahead and work through one involving the Pythagorean theorem. So we'll just sort of fill in and work through these together. So it says, given the triangle below, can you use the Pythagorean theorem to write a relationship between A, B, and C? And we know that A squared plus B squared is equal to C squared, knowing that that's a right triangle. And here I am talking about mainly my unit circle here. So I know that my radius is 1. So I know that A squared plus B squared is actually equal to 1 squared, which is 1. So cosine of my theta here is actually equal to A, and sine of theta is equal to B. So cosine of this angle right here is A over 1, and sine would be that B over 1. So we'll call them A and B. So I know, instead of writing A squared and B squared, that cosine squared theta plus sine squared theta is equal to 1 if I go ahead and substitute cosine and sine in for this A and B up here. So that is sort of the first big Pythagorean identity that we have when working with sine and cosine. So part 3 says to divide both sides by cosine squared and write the identity in the space provided. So I have cosine squared theta plus sine squared theta is equal to 1, and we'll do this in another color. This is asking me to divide by cosine squared theta, so divide everything by cosine squared theta. So here I end up getting 1 plus sine over cosine. This is going to give me, oh, that's not what I want to write. This is going to give me tan squared theta is equal to, and I know that 1 over cosine is the same thing as secant. So here I now have another Pythagorean identity. So here's 1 and here's 2. And here divide both sides by sine squared theta. So going back, I have cosine squared theta plus sine squared theta is equal to 1. And I can come in here and divide everything by sine squared theta. So here I end up getting cosine over sine, which is going to give me cotangent. So cotangent squared theta plus 1 is equal to 1 over sine squared theta, which is going to give me cosecant squared theta. So those are my 3 Pythagorean triples, or my 3 Pythagorean identities that we just used a right triangle and the relationship that we know about the Pythagorean theorem to identify with a right triangle. Here I'll do a few of these problems with you, but I really want you to work through some of them. So cosine of theta here we know is A. Sine of theta we know is B, so we're looking at this theta angle right here, and again knowing that this is in relation to a unit circle. And tan of theta we know is B over A, so cosine of theta plus alpha is, we're talking about this theta plus this angle right here. That's going to give me C. Sine theta plus alpha is going to give me D. So looking at these coordinates over here. So I'll let you fill in the rest of those. And then here we have simplify each expression. So here I just want to show you that we can go ahead and FOIL or distribute with trig functions, just like we're able to with if we were to have regular values here. So 1 times 1, that's going to give me 1 squared. 1 times sine of theta, it's going to give me plus sine of theta. Here I'm going to get minus sine of theta, and then minus sine squared theta. So, I don't know where this squared came from, out of habit. So these two pieces will simplify each other out, and I'm left with 1 minus sine squared theta as my answer there. So just as we're simplifying each expression. For part B, I can see here, the first thing that I want to do when I'm simplifying is I know that sine over cosine is tangent. So I have sine squared theta plus tangent squared theta plus cosine squared theta. And I know here that sine squared theta plus cosine squared theta is equal to 1. So I'm just going to call this 1 plus tan squared theta, which I know if I come back up here, 1 plus tan squared theta is equal to secant theta. So this whole thing simplifies to secant squared theta, and there's my final answer for that. So again, coming back and looking at these are very helpful to simplify the problems that are below. If I look at my cosine squared theta plus sine squared theta is equal to 1, here I also know that this piece right here, if I know that sine squared theta plus cosine squared theta is equal to 1, I could subtract sine squared theta from both sides and get that cosine squared theta is equal to 1 minus sine squared theta. And this is what I have here, 1 minus sine squared theta. So this is really equal to cosine squared theta as my final answer. For this last one here, this parenthesis can be ignored, and my suggestion to you would be to rewrite this using sine or cosine before you begin. And the rest of these I'll have you try to figure out on your own. So good luck with these, and nice job following along and deriving these Pythagorean theorem identities with us, and we'll keep moving forward with some practice.